Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of NEET Preparation, we'll be looking at previous year questions of chemistry in medical entrance examinations in India. Today, we'll be dealing with the chapter, the P block elements. Note that this is the chapter which is the 7th one in the grade 12 syllabus for chemistry in CBSE. Let's begin, shall we? Here lies our first question. Hypo on treatment with iodine produces H2S, Na2SO4, Na2SO3, or Na2S4O6. Well, let's find out what is hypo. Hypo is the name for sodium thiosulfate, which has the chemical formula Na2S2O3. So we need to find out the product of the reaction of Na2S2O3 and I2, which is iodine. Well, since there are two iodine atoms, they bind themselves to two of the sodium atoms, so we will have to have two molecules of sodium thiosulfate in order to satisfy. So it will have two NaI, and the remaining product will be Na2, and since there are 4 sulfur, it becomes S4, 6 oxygen, so O6. So Na2S4O6 will be the main product along with sodium iodide. Now this compound is known as sodium tetracyanate. So therefore, option D, Na2S4O6, sodium tetracyanate, is the right answer. Let's move on to our next question. Which of these is a tribasic acid? Is it A, orthophosphoric acid, B, phosphorus acid, C, hypophosphorus acid, or is it D, metaphosphoric acid? Well, in order to understand the concept of tribasic, let's discuss it in some detail. Well, a tribasic acid will have 3 replaceable hydrogen atoms, and the basicity of an acid will be measured by the amount of H hydrogen atoms or H plus ions it can displace into the solution. And in most cases, replaceable H atoms are usually bonded with O in order to form OHs. So, having said that, let's look at the structures of the 4 options. Well, option D, metaphosphoric acid, HPO3. Notice that this has only one OH arm. The other 2 arms are both containing oxygen, and oxygen has double bond with phosphorus, so it's difficult to break them off. And this is the only hydrogen present, so this is the only hydrogen that gets replaced. So HPO3 is basically a monobasic acid. Therefore, option D is incorrect. When it comes to option C, hypophosphorus acid, you see that there are 3 hydrogens present, but 2 of them are bound directly to the phosphorus, and one oxygen atom is also directly bound to phosphorus. These are difficult to break. The only hydrogen which can be easily broken is the one associated with the O. So again, H3PO2 is still a monobasic acid. So option C is incorrect. Option B, H3PO3, which is phosphorus acid, has 2 of these OH groups, and from there 2 hydrogens can be replaced. So it's dibasic. Therefore, option B is incorrect. The right answer is option A, orthophosphoric acid, or H3PO4. This has 3 OH groups in it, and therefore we can replace 3 hydrogens from this group. So therefore, when we have PO4 minus has the anion and H plus, 3H plus as the cation. So orthophosphoric acid, H3PO4, which is tribasic, is the right option. Next question. The strongest oxidizing agent is F2Cl2 I2Br2. So here we're dealing with the halogens. When it comes to elements across a period, the halogen is usually the strongest oxidizing agent. But when it comes to among halogens, the rule of thumb is that the more non-metallic character that an element has, the greater oxidizing power it has. And usually the higher non-metallic character elements are having smaller atomic radii. So when we have elements with smaller atomic radii, they have more non-metallic character, or conversely less metallic character. So therefore, among halogens, the order for atomic radii is fluorine first, then chlorine, then bromine, and then iodine. So option D, Br2 being the strongest oxidizing agent, is incorrect because it ranks third in the list. Iodine ranks fourth, so it cannot be the strongest. It must be the weakest. Chlorine ranks second, which is very strong. However, the presence of fluorine, which has all sorts of anomalous behavior and very strong oxidizing power, clinches the spot. So the strongest oxidizing agent is fluorine due to the fact that it has the smallest atomic radius and it is the most electronegative element. So therefore, option A, fluorine is the strongest oxidizing agent. Moving on to our next question. The correct order of solubility in water for He, NeAr, Kr, and Xe is, so these are the venerable noble gases. So these gases belong to group 18. And when it comes to group 18, increased atomic weight ensures more polarity, which A gives higher solubility in water, and B, it gives higher van der Waal forces. So let's constrict ourselves with solubility. So it says that when we have increased atomic weight, that leads to increased polarity. Therefore, there will be increased solubility in water. So therefore, when a noble gas weighs more in its atomic weight, then it is highly soluble in water. So when it comes to atomic weight, helium is less than neon, is less than argon, is less than krypton, is less than xenon. So therefore, xenon will have highest solubility in water. Therefore, the order for solubility will be Xe greater than Kr greater than Ar greater than Ne greater than He, which is option B. So option A will be incorrect because it says that helium is the heaviest of the noble gases, whereas it's the lightest. And option C and option D are also incorrect because these say that neon and argon are the heaviest elements, which are incorrect because they have smaller atomic masses than the highest, the heaviest element in the noble gases, which is xenon. So xenon has the highest amount of solubility in water because of its atomic weight. Therefore, option B is the correct option. Now, we have to find out the true statement for the acids of phosphorus. In this case, H3PO2, hypophosphorus acid, H3PO3, phosphorus acid, and H3PO4, orthophosphoric acid. Now, option A states that the order of their acidity is H3PO4 less than H3PO3 less than H3PO2. Now note that acidity depends on oxidation state of phosphorus. And therefore, we will have, when it comes to oxidation state, H3PO4 must have the highest amount of oxidation state. Let's check that out. O4 means there will be a total of -8, and then there will be +3. So we'll have to have +5 in order to counteract the -8. So for phosphorus, it's +5 in H3PO4. Over here, the total is -6, and then we have +3. So phosphorus must have +3. And then over here, it's -2, then -4, and we have +3. So phosphorus just needs to have +1. So you can see that H3PO4 has the highest amount of oxidation state. So it should have the highest acidity. However, the option here, option A, is giving us the inverted order. So therefore, option A is downright incorrect. What about option B? All of them are reducing in nature. Well, this is incorrect because H3PO4, which is orthophosphoric acid, is generally non-reducing because it already has 3 OH groups, and therefore it becomes non-reducing. So option B is incorrect. What about option C? All of them are tribasic acids. This is also incorrect because H3PO3 and H3PO2 are not tribasic. For H3PO2, basicity is 1, and for H3PO3, the basicity is 2. So therefore, these two are not tribasic. Option C is incorrect. Therefore, the right answer is option D. The geometry of phosphorus is tetrahedral in all of the 3 acids. And here is the structure for H3PO2, H3PO3, and H3PO4. As you can see, phosphorus always binds with an oxygen with double bond in all of the scenarios. And the other 3 bonds, which are directed downward, are with various forms of hydrogen, such as hydrogen bound with oxygen or directly bound with phosphorus. So therefore, you can see that despite the change in H or OH group being present with phosphorus, the basic core structure remains the same. Phosphorus always has 1 bond with oxygen, and then there are 3 bonds underneath for the 3 groups that are present. So therefore, the geometry here is always tetrahedral. Therefore, option D is the right option. Next question. The mixture of concentrated HCl and HNO3 made in 3:1 ratio contains ClO2, NaCl, NCl3, and N2O4. Well, what is the mixture of concentrated HCl and HNO3 made in 3:1 ratio? This is aqua regia. And for the formation of aqua regia is given in this reaction. So 3 part of HCl and 1 part of HNO3. So that means HNO3 plus 3HCl. So in this case, 1 N and 1 O reacts with 1 Cl to form NaCl, and then the other 2 oxygens combine with the 4 hydrogens present to form 2H2O, and the remaining chlorines stay as they are, nascent chlorine. So therefore, aqua regia forms NOCl, which is very effective in converting gold to gold chlorides. That's why aqua regia is so effective at dissolving gold and platinum. Next question. The element which forms the oxides in all oxidation states varying from +1 to +5 is nitrogen, phosphorus, arsenic, antimony. So let's start from antimony and write down the oxides of antimony. Antimony forms Sb2O3, Sb2O4, and Sb2O5. Over here, the oxidation state of antimony is +3 for each atom. Here it is +4, and over here it is +5. There is no +1 and +2 oxidation state for antimony, so option D is incorrect. What about arsenic? Well, arsenic has As2O3 and As2O5. As2O3 has the oxidation state of +3, and As2O5 has the oxidation state of +5. Therefore, option C is also incorrect. What about phosphorus? Phosphorus has two oxides, P4O6, P4O10. P4O6, in this case, phosphorus has an oxidation state of +3. Over here, it has an oxidation state of +5. Therefore, option B is also incorrect. The right answer is option A, nitrogen. The oxides of nitrogen include N2O, NO, N2O3, NO2, N2O5. There are many more, but these just suffice. N2O has +1, NO has +2, N2O3 has +3, NO2 has +4, N2O5 has +5 oxidation state. So therefore, option A, nitrogen, is the right option. Next question. We need to find the statement among the following which is true for N3-. This is called an azide ion. So which of these is true? A, it has a nonlinear structure. This is incorrect. Azide or N3- is always linear. So therefore option A is incorrect. What about option D? It is isoelectronic with NO2. Let's compare the number of electrons, shall we? For azide, it's N3-. So therefore 7 times 3, and then since there's a minus, so +1. Therefore, it will be 21 + 1 is equal to 22. What about NO2? Nitrogen dioxide has 7 plus 2 times of 8. So that is 16 plus 7, which is equal to 23. So therefore, as you can see, azide ion is not isoelectronic with NO2. So option D is also incorrect. What about option B? It's called a pseudohalogen. Well, none of the nitrogen group compounds are called pseudohalogens. So option B is also incorrect. What about option C, which is the right option? The formal oxidation state of nitrogen in this anion is -1. This is the only option which is correct. And in order to form an example, azides usually form metal azides, so with alkali metals. So it's usually NaN3 and then KN3, etc. And when it comes to alkaline earth, it becomes MgN3 twice. So therefore, we can see that among the alkali metals, sodium has +1, so the total formal oxidation state has to be -1. So therefore, option C, formal oxidation state of nitrogen in this anion is -1, is the right option. Let's look at our final question. For electron affinity of halogens, Which of the following is correct? And this is with respect to two of them. So when it comes to electron affinity, it usually decreases from top to bottom. But in halogens, while the expected order is F greater than Cl greater than Br greater than I, this is not true. The actual order is Cl greater than F greater than Br greater than I. The reason why is that fluorine has very small size, which causes a repulsion to new electrons. So while it might have electron affinity, but that electron affinity is somehow canceled or slightly reduced by this repulsion due to the shielding effect of the electrons already present. So therefore, the electron affinity of F is always lesser than the electron affinity of Cl. And this is one of the reasons why fluorine is mostly anomalous. So moving on, the actual order is Cl greater than F greater than Br greater than I. So therefore, option A, Br greater than F is incorrect because over here, F is greater than Br. F greater than Cl is incorrect because here Cl is greater than F, and we told the reason why, because of the repulsion of new electrons due to its very small size. What about option C? Br is greater than Cl. Again, incorrect. As you can see, Cl is way greater than Br when it comes to electron affinity. So option C is incorrect. The right answer is option D. F is greater than I. As you can see, F is over here, which is greater than Br, which is greater than I. So since Br is greater than I in terms of electron affinity and F is greater than Br in terms of electron affinity, then F has to be greater than I in terms of electron affinity. That's why option D becomes the right option. And that concludes this episode of NEET preparation. We hope you found it interesting. There are a lot of questions on this chapter. Don't forget to, watch our previous video on this chapter. We'll provide a link in the description down below. Please avail yourselves of our latest and most useful educational content at Brain Blitz Audios by subscribing to our channel. Don't forget to hit that notifications button in order to receive the latest updates from our channel. So until the next episode, take care, stay safe, bye-bye for now.